Okay, this is chapter 13d from the book Medical Reformation, and we're now going to talk about the causes of insulin resistance. Okay, um, so the first one is excessive dietary fat, especially saturated fat. That's the main cause, and the so-called overnutrition. And it's thought that sat fat is worse than the other fats because having less double bonds, you're going to produce increased electron carriers as you oxidize it. Okay, and it overwhelms electron transport on the intermitochondrial membrane and causes it to back up and to start leaking electrons, and that leads to oxidative stress with subsequent damage to DNA, activation of PARP, and then that PARP traveling, to interact with 3-PGA dehydrogenase, and you get all the advanced glycation end products. Okay, so overnutrition, insulin resistance, and you also stop sending your glucose type 4 transporters to the plasma membrane. So the bottom line is the more fat you eat, the more insulin resistance you have, especially saturated fat. You get problems from the other types of fat, the PUFAs, polyunsaturated fats, like the omega-6s, because those lead to lipid peroxidation and production of toxic aldehydes like hydroxynonenal. So all fats are bad. I've given previous talks about that idea, is that there are no good fats. That's just a slogan to trick low IQ people and make them think they need to eat fat. Okay, and the other thing is, there's always somebody trying to trick you because they want to sell you stuff. All right. So all cooking oils are bad. Olive oil is bad for you. Canola oil is bad for you. They're all bad for you. Coconut oil, they're all bad for you. Excessive amounts of animal protein are bad. Those will also activate mTOR. A lot of times too, you're going to have more manufactured free glutamate, the more like in a protein powder or something. But if you're just eating a lot of meat, you're going to get excessive amounts of animal protein. You're going to get excessive amounts of BCAA, branched chain amino acids, more activation of mTOR. Kind of what I'm saying here is it's inducing an anabolic state with elevated blood cholesterol, and that also will lead to more insulin resistance. The problem with the MSG, MFG, manufactured free glutamate, is people will tend to overeat and a lot of sodium on the food. It tastes good. Okay, I give an entire lectures on MFG and all this stuff, and that'll get you to overeat the foods, and that'll lead to insulin resistance as well. Okay, excessive alcohol leads to fatty liver. Fatty liver is like prediabetes, diabetes of the liver. Excessive dairy. Dairy is associated with increased risk of autoimmune disease, and in particular, increased risk of type 1 diabetes. We talked about this: autoimmunity, leaky gut, molecular mimicry, and autoantibody cross-reactivity to the pancreas. Okay, T. Colin Campbell writes about that a lot in his books. Okay, there's dairy. F minus water. F minus is a mitochondrial toxin. And just like I was talking about, the saturated fat has a negative effect on mitochondria. So things that are bad for mitochondria tend to worsen diabetes, okay? And there's a whole bunch of them. I given previous lectures on mitochondria inhibitors. And I told you too, you can't find them in the regular medical student biochemistry books, but then you go in the literature and you'll quickly find over 50 of them. So all these things you'll expect are gonna, worsen insulin resistance problems. Okay, excessive psychological stress, it's going to elevate your cortisol, it's going to elevate your blood glucose level. You're also going to elevate your catecholamine hormones, things like adrenaline and noradrenaline. Those are going to increase your blood lipids, they're going to increase your blood glucose level, they're going to decrease, they're going to cause increased insulin resistance, so you don't want that. So being stressed out is not good. Drinking caffeine does the same thing, being sleep deprived does the same thing. Corticosteroid medicines are analogous, and they also increase glutamate transmission in your brain at your synapses, so they're an excitotoxin as well. You don't want it. Obesity, being fat's bad because your adipose fat cells are going to spill more lipid into the blood. It's called a spillover effect, for example. Estrogenics are like a fat storage hormone. Get the person to store more fat. The baby might need it for energy, so those also are going to worsen your blood hyperlipidemia. Let's see, lack of dietary potassium and magnesium. You need those to run your membrane ion pumps and regulate your insulin secretion. So when you're low on that, you tend to be high in sodium. Okay, lack of exercise. When you exercise, you basically get insulin sensitivity effect, whereby your glucose type 4 transporters, they go up to the plasma membrane, you let glucose into the skeletal muscle cells. So that's a very good thing. It's even a good thing if you're diabetic. One of the things I would do is I would walk around while I'm eating dinner and stuff. What I mean by that is like, if no one is home, I'll sometimes walk around in circles, and I'll eat my food, and I'll play an audio book. And in a sense, like I said, there's like three different things. You're using your brain to listen to the audiobook, so that's one thing. You're eating the food, that's a visceral. So the brain listening to the audiobook's a cognitive activity. The visceral activity of eating the food and digesting it, that's a visceral activity, meaning your internal organs is the viscera. And then your body walking is musculoskeletal. So because those are all different systems in your body, you can do them all simultaneously, and it's very easy to do. You can't multitask with two things at the same time for your body. You know what I mean? You can't listen to an audiobook and at the same time listen to the words in a song. That's not going to work. But you can do three different bodily systems simultaneously very easily. Okay. But yeah, definitely exercising is one of the best things a person can do to increase insulin sensitivity. Excessive dietary iron leads to more oxidative stress. You can get ferrous redox cycling like in the blood between Fe2 plus Fe3 plus, and secondarily leading to running the Fenton reaction, for example, producing hydroxyl ions. You don't want that. Excessive copper can do something similar. It's another reason why you don't want to just randomly take some multivitamins. Sometimes they'll have iron in there, copper, or things you don't need. And we talked about, avoiding iron fortified foods, meat, and, especially like red meat, for example, have a lot of iron in it. And some cereals are iron fortified, like Raisin Bran tends to be. Okay, SERCA inhibitors. SERCA inhibitors, basically, they're like mitochondria inhibitors. They decrease the cell's ability to pump calcium out of the cytoplasm, in this case, into the endoplasmic reticulum. SERCA means sarcoplasm, endoplasmic reticulum, calcium ATPase. So really, it's the endoplasmic reticulum in most cells, but in the muscle, we'll call it the sarcoplasm. So that's where the SERCA name comes from. Okay, you need to be able to control your calcium metabolism because that can affect your insulin secretion. Okay, mitochondria inhibitors likely will increase your insulin resistance. So there's tons of those. They're in processed food. I read through a whole bunch of them recently in one of my lectures, and I think from this book as well. Okay, excessive dietary fat, especially saturated fat. We talked about that. Reverses electron transport. Too many electron carriers sent up to the inner mitochondrial membrane, not good. Sat fat also has an inhibitory effect on endothelial nitric oxide synthase. So you need nitric oxide synthase in order to get insulin access to more skeletal muscle. Excessive visceral fat, excessive obesity, that'll have a tendency to be associated with increased insulin resistance. We talked about being sedentary, just a lack of exercise. So your glucose type 4 transporters, you lose that opportunity to send them up to the plasma membrane. Okay, I kind of repeated myself a little here. Stress equivalents, yeah, we talked about all this. Okay, excessive dietary fructose. And you eat these processed foods and energy drinks. They'll come in as a bolus. We talked about how fructose is metabolized and how it leads to the production of increased uric acid. Then the uric acid is going to inhibit eNOS, endothelial nitric oxide synthase. And normally insulin needs that because insulin needs more vasodilation so it can get into the skeletal muscle and get that skeletal muscle to take up the glucose and store it as glycogen. So when you got more uric acid in the blood, hyperuricemia is just, high levels of uric acid in the blood. You're going to be inhibiting eNOS so this insulin can't get access to the skeletal muscle. Because normally the skeletal muscle vessels are constricted because if you're not using the muscle, you don't need more blood flow in there. Artificial sweeteners sort of trick the pancreas and can have a negative effect on insulin secretion. Excess dietary sodium inhibits eNOS, so that's also a problem, causing increased insulin resistance. Magnesium deficiency, like a plant deficiency, same thing as potassium is a plant deficiency. You're not eating enough plants. That'll have a negative effect. Air pollution and excess ozone, they're associated with obesity, insulin resistance, and diabetes. So, be careful where you live. If you have some control over it, you don't want to live right next to a highway or live right next to a polluting factory or coal-burning electric plant. Mitochondrial toxins, we talked about that. So just to simplify this whole thing, basically anything that causes insulin resistance will tend to cause obesity. They all go together, being fat and hypertensive. All right, now I'm just going to show some papers on this subject here. Okay, fasting hyperglycemia, glucose intolerance, pancreatic islet cell necrosis with aluminum. Okay, aluminum exposure in rats increases their amount of beta cell necrosis. Beta cells are the cells in the pancreas that make insulin. Okay, so that's bad because aluminum is quite routinely sprayed in the trails over in the sky. Aluminum is also very common in deodorants. It's a metalloestrogen as well. Aluminum is routinely put in the drinking water as a so-called clarifier. It's really a dementagen, makes people demented and stupid. It's toxic to sperm production too. That's what I meant. I'm telling you, there's billionaire whats that are trying to sterilize you. Okay, their attitude is there's too many of you useless eaters. Is how they see it. So they feel like they're doing the right thing by sterilizing you. All right, so that's one of the things contributing to it. And you'll never in a million years find any of these things in a regular medical textbook. Okay, here's something about artificial sweeteners associated with insulin resistance. The ones who use artificial sweeteners had higher insulin resistance. The duration of the artificial sweetener had a direct impact on insulin resistance. The pancreas mistakes it for glucose due to the sweet taste. So they release their insulin. Eventually it leads to decreased receptor activity. Okay. Yeah, basically you don't want to mess with Mother Nature. You want to sort of do what Mother Nature wants you to do to get the best results. Adding salt to meals as a risk factor for type 2 diabetes. Possible relationship between additional adding of salt to prepared meals and increased risk of type 2 diabetes. Approximately 2 times increased risk of type 2 diabetes in people who added salt to their food. Well, yeah, it's going to make you eat more than you should. And it also depends on what food you're eating, but it's going to increase your risk. Okay, serum dietary potassium and risk of incident type 2 diabetes mellitus. An increased risk persisted during the additional 8 years of follow-up for those with a serum potassium lower than 5. So what they're basically saying is, we've kind of talked about this before, our ancestors probably ate 25 times as much potassium as sodium, whereas in the modern world we sort of flipped it. We now eat 10 or 15 times more sodium than potassium. So people are often a little bit deficient in potassium. People are just normally deficient in the things come from plants: potassium, magnesium, and fiber and nitrates. All right, so what they're basically saying in this article is if you're low in potassium, you're at higher risk of having diabetes. Excuse me. Okay. Associations of dietary salt and hemoglobin A1C with type 2 diabetes. Reducing intake of total salt and salt from salty snacks was associated with decrease in hemoglobin A1C. So bottom line, you get better blood glucose control, improved insulin sensitivity if you decrease your dietary sodium. Okay, here's another paper. Effective magnesium deficiency on mechanisms of insulin resistance in type 2 diabetes. People with type 2 diabetes may end up in a vicious circle in which magnesium deficiency increases insulin resistance and insulin resistance increases magnesium deficiency. Okay, magnesium regulates electrical activity. Yeah, it's part of the sodium-potassium pump because it needs to bind to the ATP. Remember that, to hold the phosphates together? Okay. Intracellular magnesium concentrations are critical for the phosphorylation of the insulin receptor and other downstream kinases. So yeah, it always works in association with ATP. Low magnesium level results in a defective tyrosine kinase activity, post-receptor impairment in insulin action, altered cellular glucose transport, which promotes insulin resistance in type 2 diabetes. Yeah, once again, the stuff you need, magnesium, is located normally in the center of chlorophyll, comes from eating plants. We're just designed to eat more plants. Okay, but I'm kind of just going through these papers because let's say you have some patient with diabetes and they're having a hard time improving their insulin sensitivity, then they should pay extra care to all these additional things that contribute to it besides just dietary fat. Okay, plants have the good stuff, meat is the bad stuff. Increased sympathetic effect, which does come in part from hyperinsulinemia, high levels of blood insulin, causes more urinary loss of magnesium. So that loss of magnesium in the urine can lead to more hypertension and a kind of vicious cycle. Positive feedback on itself cycle. Excuse me. Harder to quench. Okay, endocrine disruptors in plastics. Alter beta cell physiology, increase the risk of diabetes. Okay, so these endocrine disruptors, things like bisphenols, they'll worsen. So this is all these estrogenic chemicals, and the phthalates to go with that as well. Oh, here's something about perfluorooctanoic acid induces oxidative damage and mitochondrial dysfunction in pancreatic beta cells. Environmental contaminants are associated with diabetes. This is from surfactants, lubricants. It's also found from nonstick pans, POFA, okay, perfluorooctanoic acid. And they detect it in people. It's another reason why I don't use those nonstick pans. I think they're a bad idea. Excuse me. PFOA significantly decreased cell viability, increased apoptosis, increased reactive oxygen species, mitochondrial superoxide, that's the free radical, or the reactive oxygen species, mitochondrial membrane potential collapse. So yeah, avoid nonstick cookware. Okay, they also tend to often have obstructive sleep apnea, which can be due to hypoxia at night, but it can also be a problem if you're combining that with low blood sugars because you're taking too much insulin. Once you got a continuous glucose monitor, you can check that. But if you got a continuous, low blood glucose at night and you're also hypoxic, that's a bad combination. You put increased risk for your neurons to die. These are just normal and abnormal hemoglobin A1C values. So normal hemoglobin A1C is below 5.5 or a fasting blood sugar below 100. Prediabetes is a hemoglobin A1C over 5.5 or fasting blood sugar, 100 to 126. Full diabetes is hemoglobin A1C over 6.5 or fasting blood sugar greater than 126. Hemoglobin greater than 7 is considered, poorly controlled or uncontrolled diabetes. Here's a little about the mouse equivalence ejectile torrie. We talked about that before. Okay, let's see here. So what's the point? If a pill lowers blood pressure too much, it becomes a mouse equivalent, can predispose to dementia. Okay, so the purpose of showing this was just to explain how diabetes contributes to causing dementia. Here's this picture right here is a good slide. This is actually one you might want to hit your print screen button for. So normally the red blood cells are passing through the capillary. The red blood cells are a little bigger than the capillary. They're about 7 microns. Capillary is about 5 microns in diameter, so they have to deform to fit through there. Over time with diabetes, the capillary basement membrane thickens. These little blue circles are oxygen. So what that means is they're going to be less able to deliver oxygen to the tissue, in this case a neuron, because the capillary basement membrane is thickened. Also, you can get thickening the vascular smooth muscle cells. You'll also get increased collagen laid down in these areas. That's worse with diabetes, worse with hypertension. And if you got a lot of glyphosate on board, that could be damaging the collagen. A lot of F minus, that could be damaging the collagen. So all these things make it more difficult for the red blood cell to deliver their oxygen to the neuron. And if you don't get enough oxygen to your brain, you become stupider. Here's another thing. This is about insulin resistance in the brain. They used to think you only have glucose type 1 and type 3 transporters, which are not insulin dependent in the brain, but it turns out you do have glucose type 4 transporters that are require insulin in your brain, including your hippocampus, your substantia nigra. So hippocampus is your memory center. Substantia nigra is in the midbrain. It's associated with Parkinson's disease. So insulin resistance has a negative effect on both, on glucose uptake in your neurons in these areas of your brain. So that's a real important point. Glucose type 4 transporters are present on neurons. Okay, here's another thing. So if you got insulin resistance because you need to be able to use your glucose type 4 transporters, you'll get less glucose into the cell, and that'll decrease cognitive function. And here's another thing. You've got something between your endoplasmic reticulum and your mitochondria and neurons called a MAM, a mitochondria-associated membrane. And what that's for is when you suddenly have to ramp up activity. You're walking through a path in the forest, and you see a bunch of coyotes. Uh-oh, you got to run, climb a tree or something. You have to very quickly ramp up neuronal activity. And so they have a mechanism to do that. The endoplasmic reticulum can quickly allow calcium to enter the mitochondrial matrix. And when this happens, normally the mitochondria will upregulate their Krebs cycle enzymes, but this is dependent on the assumption that more glucose is going to be coming in. So if you've got insulin resistance and you're not responding to this insulin binding the insulin receptor, then these glucose 4 don't get their signal to come up to the plasma membrane and allow glucose to come in. And you need that glucose to be able to run all these reactions in Krebs cycle. So what happens is, I think our ancestors didn't have this happen too often because they ate low-fat diets, and so they'll get too much calcium coming in the matrix, and if that accumulates at too high of a level, it'll precipitate the mitochondria and become solid, come out of solution, and it'll die. So that's why diabetics are kind of notorious for having poor cognitive function. And they just keep losing more neurons from apoptosis. So I kind of feel sorry for them, but I can just tell you from talking to a lot of diabetics, they're usually real mentally slow, especially as they get older. The longer they've had their type 2 diabetes and the more cognitively impaired they get, the less likely they'll ever get better. So anyways, I hope that was helpful.